Today on Earth Focus, increasing droughts may limit our ability to grow food. A National Science Foundation project may have the solution. It's in the roots. Penn State's Dr. Jonathan Lynch shares his cutting-edge findings with correspondent Miles Benson. Coming up on Earth Focus.
Today I want to talk about something that most of you already know. It's hot outside. It's really hot. And if this feels worse than normal, that's because it is. We just found out that July was the warmest month on record. Warmer than any other month since we began keeping track more than a century ago. On top of all this heat, we're also experiencing one of the worst droughts in over 50 years.
The U.S. was not alone in suffering crop losses in 2012. Droughts were also reported in Africa, Europe, and Asia. Rainfall is less predictable, and in 30 years, there will be 2 billion more people, most in countries least able to feed them. Providing food for more people in a worsening environment is an unprecedented challenge. But scientists at Penn State say adapting plants to stressful conditions like lack of water may be the answer.
Jonathan Lynch, we're in your greenhouse. It's part of your research laboratory system. What's going on here?
Well, what we're doing here is growing plants under stress conditions, meaning conditions that plants don't like. In the third world, in developing countries, people cannot afford to irrigate and fertilize their crops. And that's one reason there's 1 billion hungry people on the planet. Now, 1 billion hungry people is more hungry people than we've ever had in the history of our species. So you've got a challenge our species is going to have to confront that's really unprecedented, which is, how do you sustainably feed a population of 9 or 10 billion? Most of the world is actually low input agriculture. They cannot afford fertilizers and irrigation, so the crops have to deal with low soil fertility and drought. Drought, of course, is even a problem in countries like the US. But we're trying to understand how we can get plants to adapt to these conditions and grow better despite these stresses.
How can you grow crops without nutrients and water?
Your grandmother would probably tell you that if you want a plant that was going to do well under drought conditions or poor soils, you need a good root system. Certainly any farmer will tell you that you need a good root system. And scientists have known this for many years. Roots are important for getting water and nutrients out of the soil. But what exactly is it about roots that is most important for that? What's the difference between a good root system and a bad root system? How do we select plants that have better root systems? One of the main components of a good root system is having a good architecture, meaning the shape of the root system, how it's arranged, where it is in the soil. The main backbone roots of a root system are the main structural, architectural scaffolding of a root system from which lateral roots emerge and all the finer roots emerge. Those are called axial roots, and they can be sort of shallow, going out in the topsoil from a plant, or they can be deep. Surprisingly, this is the kind of thing that, in retrospect is obvious, but it hadn't been done before. We found genetic variation for that, those angles, those growth angles. So plants that had shallow roots were much better at taking up phosphorus, which is in the topsoil. Plants that have deep roots were much better at taking up water. Well, there's a trade-off here. You can get good phosphorus acquisition by having shallow roots, but at the cost of reduced water acquisition, reduced drought tolerance. And we had a student show that in the field in Honduras, that if you had shallow-rooted plants, you'll have a significant growth advantage under low phosphorus, but you're going to become more drought sensitive. If you have deep-rooted plants, you'll have significantly improved drought tolerance, but now you're not taking up the phosphorus. See, now that's a problem, because in Honduras or in developing countries, they have both drought and low soil fertility.
Are there some plants that could combine both systems, root systems nearer to the surface and root systems that go deep?
We think we have discovered a trait that would help us get shallow and deep. And we're working on a couple more traits, ways we can combine topsoil foraging or topsoil exploration with subsoil exploration. But this is exactly why research is needed. Nobody knows the answer to your question. Nobody knows, can we really get a plant that can do both shallow and deep well without reducing yield? We have ideas, we have hypotheses, but they have to be verified with actual plants in the field before breeders are going to believe them. We think we have some solutions by trying to develop plants that put roots where the goodies are, where the phosphorus is, where the nitrogen is, where the water is. That's how we're going to improve crop production in these stressful environments. But in these poor countries, people may not be literate, they may not have access to government services, they may not have much money or capability to do some sort of new farming system, or they don't have machinery. One thing they can do is plant a new seed. They're planting seeds now. If you give them a better seed, suddenly they might get significantly more food and more yield. So that's an important improvement there. In the US, if we had corn plants that needed less fertilizer, then we could reduce the cost of growing corn for American farmers, and we could reduce the environmental impact.
How far off is the end result?
We have already had impact with our work. There are bean varieties being grown today in Africa, Asia, and Latin America that have better root traits because of our work, that have better yield in low fertility soils and drought-prone soils. That's happening today. We can double or triple yields without fertilizer just by selecting for these better root traits. When we look at maize lines that have these good root traits for nitrogen and water acquisition, we're talking about maybe a 3- to 4-fold increase in yield under drought in a recent study. In a study we published last year, we had an 8-fold increase in yield under drought. That's 8 times more yield without water. So we're, instead of putting on more fertilizers, putting on more water, we're just selecting for a better seed. And by having a better root system, then we can have a much better crop. So we're already achieving impact, and I think the impact is going to continue. The overall picture is that we're at a moment in human history where we're really coming up against biological limits of what we can do. We can't just assume that we'll be able to continue making more fertilizer, putting on more irrigation systems. There aren't enough resources to go around. We can make progress on this problem. We can improve yields. Well, we can do that. It's not going to take some kind of, magic technology that hasn't been invented yet. We can do this using conventional plant breeding, just using common sense.
Airwaves, a global channel of uncompromising stories, world news, documentaries, entertainment, and culture. Link TV, connecting you to the world. For more information, visit linktv.org.